Okay, so today we're going to go over transformations of functions, and we're just going to focus on shifting functions up, down, left, and right. This one's going to be slightly different than how we typically run a lesson. I'm going to do this first example A and B, and then I'm going to let you guys work for a while, and then we're going to come together, and then we're going to finish the worksheet together. Just because it's easier for you guys to work on this and explore and do things like that. And I'll walk around and answer questions that way. So example 1A says, consider the graph of f of x equals the square root of x. We've got a lovely picture there. That's the square root of x. You can type it into Desmos. If you're typing it into Desmos, it's SQRT. And as soon as I put my t, it's going to give me a square root. And if you type in the x, you get the square root of x. On your calculators, if you hit y equals, and you hit the second key, and then this little squared key, you get the square root. And you can hit graph. You get the square root as well. I'm going to use Desmos for the rest of this class because this calculator and Zoom seem to crash each other, sadly. Okay, so we have the square root function. It has all the famous properties of a square root. We have the 0.00, and we have the 0.11, and then we have the 0.42. If I'm looking at a square root function, those are the three major points that I'm going to look at. Part B, we can't read some of this. Sorry about that, guys. I will fix that for next semester. Write a new function g of x, which looks like f of x, which is the square root of x, but shifted up 3 units. Graph your new function and make sure it works. So I'm going to graph my old one in red. We have the square root function, and I told you we had the 0.00, 11, and then 42. And the square root function looks like this. But now we want to graph it, shift it up 3 units. We want to like pick this whole graph up, move it 3 units up, and flop it back down. And so graphically, what this looks like, we had the 0.00, and now I want to move that up 3. So I'm going to have the 0.03. And I have the 0.11, and I'm going to want to pick that point up and just move it up 3 and plop it back down. So I'm going to have the 0.14. And then I had the 0.42, again, picking it up, move it up 3 spaces, flop it back down, and that gives me the 0.45. And so we get these new points. My graph doesn't look very good this time. There we go. And so we get this new equation. Notice that the x's didn't move at all, right? But the y's did. It's like I took my entire equation, my entire y function, and added 3 to it. Would everyone agree with that? So I took my entire y function and added 3 to it. And so when I'm doing that, what that actually turns into is my new function g of x is my old function f of x added 3 to it, which is really the same thing as the square root of x plus 3. And I can try this and make sure it works in Desmos. So I'm going to go into Desmos. I'm going to leave my original function. I'm going to type in my new function. And then I'm going to add 3. And it's been shifted up 3. And you can move it around so it's a little bit better view. So that worked. That did exactly what we wanted it to do. All right. Any questions about this? All right. So this worksheet is really meant for you guys to explore and to try these on your own and to work with Desmos, work with your calculators. Go ahead and pair up with people around you, try and work with them. I will give you till the 30-minute mark, and then we'll come back together. So 15 minutes, and then we'll come back together for the last 20 minutes of class, and I'll go through this. All right, so part C says write a new function h of x, which looks like f of x, which is the square root of x, but it's been shifted down 3 units. Graph your new function with to make sure it works. Whew. All right, so I kind of do these backwards of the instructions. I always graph them by hand first, and then I use my calculator to make sure that what I typed in worked. So we want to shift it down 3. And we get a graph that kind of looks like this. Something around there. With a square root function. And what I'm doing is I'm taking my entire function and moving it down 3. So my h of x is my entire function, but moved down 3 units. And so if I'm plugging my function in, I get the square root of x minus 3. Can graph this in Desmos. I'm just going to change my plus to a minus. Okay, and that is exactly what I want it to do. It shifted it down 3 units. Okay, any questions about this one? All right. Example 2, pretty much continue it from example 1. We have our square root of x. Write a new function g of x, which looks like f of x, which is a square root of x, but it's been shifted to the right 3 units. So if I'm writing this graph, moving to the right, I have 3, 0, 4, 1, and then I had 4, 2, so it'd be 7, 2, 5, 6, 7. So it looks like this. And what I normally tell people when they're just trying things out is notice up here, we subtracted or added outside of the function. So that means I should probably try adding or subtracting inside of the function. Intuition tells me that this should be, I'm going to put a star by it. Intuition tells me that this should be the square root of x plus 3. Go check it out. So when I go into Desmos, hey, that didn't work. It didn't do what I wanted it to do at all. It moved it to the left. So my other thing that I might try is a -3. Okay, that worked. So I know that my function, my intuition didn't help me here, but this should be -3. So this is f of x -3. Now, why in the world would I do a minus to move it to the right instead of doing a plus? So if we think about that point 0, 0, that's the point that I'm going to think about right here. I want 3, 0 to have that same kind of point as 0, 0 before. So when I plug in a number in for x, I want it, actually, when I plug in a 3 in for x, I want it to have that 0 output, right? So I need to do something to this x so that when I plug in a +3, I get a 0 y value out. So if I do 3 minus 3, I get 0 to the square root of 0 to 0. So it's a little backwards on these. You start with your new function, and you see, how can I get back to that original? How can I make that y value work for what I want it to do? And it's a little bit backwards from what we're used to thinking. All right, any questions for this? On accident, we already figured out c. And we wanted to create a new function h of x, which looks like the square root of x, but shifted left 3. And so h of x, we already found was our function f, but added 3 to it. So the square root of x plus 3. And the way I look at, when I shift left and right, the way I look at this is I'm taking x and I'm replacing all of my x's with a function that allows me to shift it left and right. So if I know that I need to put in x plus 3, I'm taking every single x and replacing it with x plus 3. Questions? All right. Example 3 is pretty much making some rules to generalize these. So if I want to shift a function up, using function notation, I can say this is f of x plus some a, and I'm moving it up a units. We can also write this another way if we want to use a less algebraic notation. If we wanted to use words, we're going to add a to the entire. That's not spelled right. I'm sorry, guys. We're going to add a to the entire function, or add that number to the entire function to shift it up or down. So a more general statement. There. All right, so if I want to move it down, I take my entire function, my whole function, and I subtract a from it. We're assuming a is a positive number right now. And so what that does is it moves it down a units. And putting this in words, we can subtract a from the whole function. So if we subtract a from that whole function, we're moving it down. Part B, can you make a rule to shift the function left? What about shifting the function right? So if I'm moving the function left, what I'm going to do is it's going to be f of x plus a shifts left a units. But the way I will probably say it for the rest of the class, because to me it just intuitively makes a little bit more sense and it helps me remember what I'm actually doing, is I'm replacing x with x plus a. So I'm taking that x value and every single x value, every single one, all of them, every single one that's in the function, you take it and you replace it with x plus a. And then move to the right. We have f of x minus a shifts right a units. Or you can think of it as replacing x with x minus a. So every single x that I see, I'm going to pluck that out and I'm going to rewrite it as x minus some number. All right, questions? Example 5, we want to write one function, a function, which describes the graph of f of x equals absolute value of x, which has been 1 shifted up 4 units and then shifted right 7 units. I will write all of these like this, especially on the test. So make sure that you're writing this as one function. So we want a new function, g of x. And my base function is the absolute value of something. I'm just going to put my lines there. And the first thing I'm going to do is I'm going to shift it up 4 units. Shifting up, we add 4. Okay, then the next thing I want to do is I want to shift it to the right 7 units. And that means I'm going to take x and replace it with x minus 7. So I did have an x right here, but instead of writing x, I'm now going to write x minus 7. Okay, questions on this? All right, example 6, write a function which describes the graph of f of x, which is x squared plus 5x plus 4, which has been shifted down 3 units and then shifted left 2 units. The kind of base function that I have will be g of x equals something squared plus 5 times something plus 4. This is my base function. When I shift it down 3 units, let's use purple for this. When I shift down 3 units, I take my entire function and subtract 3. So I'm going to subtract 3. And then I want to shift left 2 units. So I'm going to take every single x that I had and replace it with x plus 2. And I had an x here, and I had an x here. So every single one of them is going to be replaced with x plus 2. And you're done. I'm okay if you leave it right here. If you want to simplify further, you can. When I'm grading, what I'm grading for is, did they shift it down? So did they have that -3? And did they shift it left? So did they have these pieces? So if I'm grading a test, if you simplified it, I'm just going to jump up to your first one where you inserted things in. Okay, questions? All right. Whew. Example 7. State the equation that defines the following graph. You can graph to see if your answer was correct. And the ones before, you can also graph in Desmos or on your graphing calculator just to double check, like, hey, this was my base function. Did it move correctly? And if you're on a test, I very much suggest that you do that. So the first thing I want to do is grab, what is my parent function? What is the parent function of this? X squared. So first things first, parent function is y equals x squared. The second thing is, an x squared looks something like that. How did x squared get shifted? Yeah, over to the right 2 and up 1. So it moved up 1 and to the right 2 units. If you write this on your test, you will at least get partial credit if you write the equation wrong. Did everyone hear that? If you do this incorrectly on your test, but you have the setup correct, you will at least get partial credit. So my new function, g of x, we know we had something squared. And I moved it up 1. So I'm going to add 1 to that entire function. And then I moved it to the right. I don't know why the computer screen is glitching. To the right 2, which means I'm going to replace every single x with x minus 2. Okay. Questions? All right, last example. State the equation which defines the following graph. You can graph it to see if your answer was correct. So what is the parent function of this? My parent function, I heard x cubed or cubed root. If you're not sure, graph them. So I'm going to go to Desmos and I'm going to type in x cubed into 1. Oops. And x to the 1/3 into the other. So does our graph look more like the red one or the blue one? The red one. So it's a cubed root. So my parent function is y equals x to the 1/3. Okay, so now I'm going to write down my shifts. And how was it shifted? Yeah, it was shifted over to the left 3. And what I'm doing is I'm looking at that 0, 0. And I'm finding that point on the x cube and seeing where it moved. So it shifted over left 3 up 2. And so we get the function h of x is equal to something to the 1/3. My up 2, I add 2 to the entire function. And then my left 3, I'm going to replace x with x plus 3. Okay, any questions? All right, have a wonderful, wonderful weekend. I will see you on Monday.